Hello, everyone, and welcome to Paris Video Tech's Apéro Vidéo Confiné. This is our first virtual event of the year, first virtual event ever, actually. I guess we're a bit late on the bandwagon of virtual events, but we did obviously want to get the community together before the end of the year and keep up contact and say hello and bring it together for some good tech talks before we head into what we hope will be a much better 2021. So welcome. Thanks so much for joining us. We have a great program lined up for you tonight, and we're looking forward to kicking it off. So before kind of getting started into the program and into what we'll be doing this afternoon, as always, our kind of public service announcement for Paris Video Tech. We obviously want to go back to in-person events as soon as it's safe, and we will hopefully be able to begin organizing those as of, when we can in 2021. We will keep you posted. As always, we're looking for volunteers. If you would like to help out with the organization of the meetup, lend your skills in marketing, in organization, in anything that you might like to do to help us out, we are looking for volunteers to be members of our association and to help out with organizing our events, our Paris Video Tech events. We're also obviously looking for donations. 100% of all of donations given go into our events and have been helpful in the past to allow us to treat you to some of the events that we've done in the past. We're looking for speakers, always looking for really good tech talks. And finally, we are, as we go into and start thinking about 2021, we also want to, as we think about going back to in-person events, which seems pretty unthinkable right now, but we are, the community is growing, and we are looking to have venues of at least 150 people going into 2021. So thanks so much, and hello to everyone. Here's one second. A big thanks to our sponsor, ATEME, for making this happen today and supporting us in this virtual event. For those who do not know ATEME is a global leader in advanced video delivery infrastructure and a world-leading provider of multi-format, bandwidth-efficient compression technology. They recently acquired Anivia this year and are now counting about 430 employees, including some of the best video experts in the industry. And we'll actually be hearing from the ATEME CTO later today. So thank you so much for supporting us and helping us make this event possible. Moving on to our program for tonight. So we have about, we have 4 talks for you, all of about 20 minutes, 25 minutes. That will be followed by questions. We will take a break in the middle so that you can stretch your legs or do whatever you need to, get what you need for your apéro. But we'll have 4 talks, probably lasting about 2.5 hours, 3 hours. So we're going to start out with Newsbridge, that will be giving a presentation on AI and how to use it to index thousands of streams in parallel. Romain will then be talking to us about standardization and the making of our favorite standards. And then we're going to finish out the second half of the evening with 2 talks on low latency and more precisely in CMAF, the first from Harmonic and the second from ATEME. So I am going to pass the mic to Simon, who is going to explain the chat feature, which it looks like everyone has already pretty much understood. But I'm going to start talking about some of the question and answer and how that's going to work. And I will see you a bit later, and we'll kick it off.
Thank you, Erica. Yeah, so as Erica mentioned, it's our first virtual meeting, so it's a new tool that we are testing out for this meeting. So please feel free to use the chat to discuss whatever you want. But ask all the questions you want to ask the speakers in the question tab. And so at the end of each of the presentation, we'll go over all the questions you might have had in the question tab. The speakers will answer you. So without further ado, let me launch the first So from our friends at Newsbridge.
Hello everyone, my name is Frederic Petitpont. I'm the CTO and co-founder of a company called Newsbridge. And today we're going to discuss about how you can use AI to analyze up to 1,000 video streams using big data technologies. Newsbridge is a company made of 20 talents. We got, on one hand, experts from the broadcast industry, and on the other hand, we got talent from the AI, big data, and machine learning fields. Our mission is to help our customer identify the most relevant part of their content, whether it's live content or file-based content, using cognitive technologies. We're working on live ingestion, live analysis, and archive valorization and monetization. Our customers are made of several different fields. We got the broadcast industry and media, press agencies, and sports rights holder. And basically, they got something in common that is really unexpected events or massive big contribution. So let's take the example of a press agency. It's really, most of the time, nothing will really happen, right? It will be business as usual. But let's say you got an unexpected event like a tweet from Donald Trump. Well, you may have a high rise of contribution at the same time, yet you need to manage. And that makes this challenge very interesting. It's really close to, even if you don't have any live content, when we are, for example, working with M6 and they're sending all their episodes of Objective Top Chef, for example, you got hundreds of hours to analyze in 10 minutes. So really, our promise for them, whether it's a press agency or rights holder, is to process them as close to real time as possible. So the thing is, how are we going to do that? How we can achieve that? Well, I can have this turn of speech and saying, well, you know, we are in the cloud, so we got almost unlimited CPU and GPU power, so it's not a problem. But the truth is a bit different, because it's not because you got an unlimited amount of power that you can achieve this, right? Having unlimited amount of CPU and GPU will definitely create bottlenecks somewhere else. So your database or your storage space or you name it. And the thing is, the closer you will work on this bottleneck, the closer you will get closer to another industry. You will end up having problems and issues that are closer to Walmart opening a PS5 pre-ordering campaign, right? And that is called back pressure. The back pressure is basically, well, you are an unexpected amount of event coming in, and you need to manage that. And this is really what we need to deal with here. And let's see how others are doing it, right? Let's see the Uber way of doing it. So Uber, they claim to manage trillions of events every day. Trillion of events. That's massive. We can understand that. It's all across the world. You got the rider app, you got the driver app, you got many applications that are actually sending content. So the first thing they did is to actually use a broker. So in their case, they use Apache Kafka, which is a broker made by the Apache Foundation. This is the one we are using it too. And in the previous Paris Video Tech talk, this is a technology that was already discussed in some presentation. I will get into details a bit later. But what we can see is this Kafka broker is used as a kind of buffer. You see, you log a lot of events, and then you got consumer applications that are autonomous, asynchronous, and that can scale their own way. And that's interesting insights here. And the question is, well, processing trillion of text events is one thing, but processing hour and hour of video content is another thing. And I think we can apply things, but we need to manage our expectation. This cannot be exactly the same architecture, right? So the first step is to actually make sure your content is highly available. And this is not actually the way we started it. And we realized this very quickly. When you are cloud native, you can make a good leverage of cloud object storage, right? You got virtually unlimited amount of bandwidth. That's very cool. but you got one major trade-off on object storage. Your file, your content is only visible at the end of the transmission. So it means that if you are sending 12 gigabyte file, it will be only accessible at the end of the transfer, at the end of the upload. And that's one major trade-off if you want to process everything real time. So the idea here is to leverage the use of HLS. Basically, it's exactly the same problem when you want to distribute a live content to thousands of users. Well, we are doing exactly the same thing. And in our situation, we don't need to worry too much about the cost because we don't have thousands of viewers of the content. We'll have a dozen applications and that's all. So by sending small TS chunk, 3, 4, 5 seconds TS chunk and a manifest there, the content can be consumed on the fly by any other application. But that's the first thing. Your content is highly accessible. And then what we learn is to actually distribute more the business logic. And I like this GIF. I don't know if you know that this game is a game called Factorio, where basically you are alone on a hostile planet, and you need to build a starship to actually get out of it. And you need to build a factory that is 100% autonomous. So in this situation, well, it's actually the same. You use a broker, just the same as Uber is doing it. So here you basically have steel plates. You got a producer that is building steel plates, pushing it to a conveyor. That's what we're going to call a topic. And then you got a consumer, which is basically the factory that is building the small bearing wheels. If you want to read more, there is a nice Medium blog post here. The link is in the presentation. They got every scenario in Kafka that is illustrated with a GIF. It's really cool. In a more formal way, it looks like that. You got a producer there on the top here. You got topics, which are basically linked to your business logic. You can have like one ingestion topic, one QC topic. You can have face detection topic, you name it. And then you got consumers that are basically reading these events. Now, the beauty about that is if you got a lot of content, a lot of TS chunk here, this topic will act as a buffer. And each consumer will scale and read at his own speed. And that's what is really cool here. This is the way we are doing it. On one hand, you got the TS chunk written event. You got a first row of consumers, a sum generator, transcoding, scene detection. In the case of a scene detection, we are clustering frames together. So it's going to be easy to actually apply computer vision and transcription there. So we are pushing the scene and this frame cluster to the face detection logic, and it's consumed by this consumer. And here, of course, we're not sending raw frames across all these tubes. We're just sending reference to the object storage layer with a TC in, TC out. And then when you're a consumer, like the face detection consumer, you will read, instead of reading every frame, you would just read this scene, read it from the object storage, and then push the result to another topic. It's the same when you are doing transcription. We are looking if there is any voice on the scene, and then we are pushing it to the diarization and transcription pipeline. So that's really the way it's working. And the thing is, if you got a back pressure problem, you got multiple buffers here, and you actually won't crash your infrastructure. You will just need to scale it, otherwise you will have some latency. But at the difference on the GIF we see when you have the crowd in front of the supermarket, the crowd is not going to break the door. That's fine. They will just pile up. That's another problem, right? The third thing is when you are using computer vision, there come another issue, which is a lot of data, right? So you got all the objects that are detected in the field, you got logos, you got faces, you got a lot of stuff. And in this stuff, there are some things that are relevant, there are some things that are not relevant, and there are also false positive. False positive is really the disease of AI. It's basically mistaking someone from someone else. And the way we are doing it is to actually compute every second, every minute, we are computing the confidence to make sure we are displaying results that are consistent. So let's take this example, Antoine Griezmann. So we saw his face, right? But we don't assume it's him yet. We're going to see if his name is in the transcription, the name entity. We're going to see if there is any other context, like a logo that can be associated to it. And then we are doing data fusion. So we are merging the results to actually recompute the confidence. And that is called multimodal AI. Multimodal AI is used a lot in on research field, in the medical research field. And we are using the same principle here to boost up the result. The beauty about having both audio and video and context is you can actually use all this data to compute more relevant, more precise results. But the trade-off is you got to manage a lot of data. And it means that if we go back to our initial issue, if you got 1,000 video stream, you got 1,000 things that are detected every minute or maybe every second. So you need to manage that. And if you go a classic way and use synchronous database access, that's going to be a problem because you will create a bottleneck on the database. So we need to have a smarter way to manage our I/O operations. And there really come a technology we started from day one to use is called ACA. So ACA is a framework. We are implementing it in Scala. And ACA is also used for other applications such as LinkedIn to manage data streaming, and all the business logic is done like that. See ACA as a node infrastructure. It's based on an actor model, and it's very easy to manage your thread. Actually, you don't need to manage them at all. The base of the actor model is you have an actor, which is your application. Each actor has its own kind of mailbox. And rather than expecting a direct answer, you are sending an event that will actually do the business logic, and you will have the answer later. So that's a bit like the idea of having a producer, a topic, and a consumer. Here, if you got a back pressure issue, you will have the mailbox that will hold all the events. So your bottleneck here is more related to your memory. But as you can see, you can have many different actors, and they can actually spread the load for you. And one beauty about this infrastructure, and we'll see this a bit later, is you don't need any load balancer. And that's the thing that is really cool. Let's get back to our issue with fake detection. So you got many events. Of course, you need to analyze and create occurrence event at each TC where you detected someone, but you also need to inform the users of what's going on. So every time we got an update in the occurrences and face detected, we are broadcasting WebSocket event to update UI and making sure that the users can see what happened in real time. And that's very useful for press agencies, for example, because they can trigger alerts. Once Antoine Griezmann is detected, or let's say Angela Merkel, for instance, I can generate a notification to journalists, and they come back to the platform and actually see the content. So Antoine Griezmann, once we got frame that started to be analyzed, we got an actor that is instantiated. So in these schematics, you can see all the node with the ACA logo as an instance, like a separate machine. And a small blue bubble here are actors that are instantiated on each machine. You can have as many as you want. It's not really a problem. So the thing is, we got Antoine Griezmann that was spotted, so the system is popping it up an Antoine Griezmann actor for a specific workspace. It's using a singleton pattern, so you only have one. And when you need to display it, you don't care about which instance. You don't care about which load balancer you should be calling. And that's the beauty about ACA is you don't know where the data is. You don't know on which business logic Antoine Griezmann is. It doesn't matter. You're just calling the region, calling the cluster, and you will get an answer. So you got a system of proxies that will redirect the question to the right node, to the right actor, and you will get an answer. And the beauty about that is it's very helpful to make it more resilient and to have it scaling up and down. Let's say a node is down for whatever the reason is, if, I don't know, you want to remove it manually or whatever the reason, well, the thing is the system will automatically move this Antoine Griezmann actor to another section, to another machine, and instantiate it there. And you won't see the difference. You won't notice the difference. And that's very easy then to scale up and down your cluster. When we're talking about auto-scaling strategy, most of the time, auto-scaling up, scaling up is easy. Well, I just need to add as many instances I want. But scaling down, that's a hell lot of different thing. Because if you kill your instance that is already have some business logic or data that was persisted on this machine, you may end up losing stuff. It's not the case here. It was built to be that way. And this is what we really like about that. Akka can work this way because they are using a protocol that is called the gossip. It's really like we mean it. Every machine is actually looking one after each other. And once you got a quorum of machines saying, well, this node, it doesn't smell good, let's get rid of it, it will put the node down because it had maybe the response time was too high, or you can adjust as many criteria as you want, but it will be the same when you got a new node that is coming in. You will have a quorum. Well, hello, new node, you can join the cluster. And that way, you don't need to have internal load balancers or active-passive redundancy. It's way easier. And this is what we realize is the first scaling is done at the software level. And that's one key learning here. From the very beginning, if you are using this kind of model, you can distribute the business logic really the way you want. Then, of course, there is a scaling that is more on the infrastructure. And you can start small, but we notice that you got to be very careful. When you're starting working with a customer, sometimes you're just instancing one machine. And you end up customizing the machine and adding stuff. And, well, this is my first node in Akka, but that might be the only node. And it's so customized, so tailored that you cannot pop other instances like this. And this is a traditional issue we call that you can have a pet, a very single instance that is very customized, and you can see it as cattle. The way we see cattle is infra as code. You are basically scripting every code, every installation you need. It's not just about using Docker, right? It's about building the Docker image automatically. It's about popping new instances. It's about auto-scaling rules and making sure that when you don't need an instance anymore, well, you are killing it. And when you need one, well, you are booting one fresh up. And that way, if you got any security issue or storage space, you don't care. Any instance, new instance is up. And that's really the last learning here is about that one. And it's not very easy to start up with always this solution because it takes a bit more time. But in the end, it's really helping us scaling up and make our customer happy. So key takeaway is, well, first thing is making our content highly accessible using object storage and a chunk format like LL-HLS. Second one is we got to be very careful about data access, not create bottlenecks somewhere else. Of course, you can analyze up to 1,000 video stream, that's fine, but it's going to generate so many events that you may end up having bottleneck on places you didn't think, like a logging system, for example. Be very careful about having not too much instances that are customers and tailored that you cannot scale, of course. And the last thing is about distributing the business logic. And for us, it's not just about scaling from a technical standpoint. When we are using Kafka, the beauty about that is you can distribute the workload, and then it can match our human organization. The key idea when you got we have PhD working at Newsbridge, and let's say if we got a single monolith, yeah, it's not an ideal situation to actually try a new feature or develop something else. But when you got Kafka, you can actually distribute it. Managing the scaling of a product from a technical point of view is not really that complicated, right? But scaling a team is different. scaling a team is you need to hire team and talent that are basically working on the same language and make them work together. And when you got software engineer, Scala software engineer working on akka, it's very different than when you got PhD and AI researcher working in Python on neural networks. And you got to make sure all of them can work together and share the same event and the same data. And Kafka here is really great for that, because when you want to add a feature, you can add a new consumer, you can add its own scaling rules, and you can deploy it and maintain it the way you want at the speed you want. And this is really the best learning we had using Kafka is this. You can scale your team and improve the developer experience working on a daily basis. There is also discussion about using Hadoop. Hadoop, I think maybe you have seen something on the web like doing transcoding on Hadoop. I didn't mention it here. It's very interesting too, but I cannot talk about everything, unfortunately. Many thanks for all being here. If you are interested in Newsbridge Challenge, we are hiring a lot these days, many engineers, so we are a lot of things to do and happy to share. Otherwise, we're here to answer all your questions. Thank you very much for listening.
Thank you, Frederic. If you can join me on here to answer the question. Thank you. So let's go to the questions. So we have the first one. So you gave the example of Uber using Kafka for large number of events, which is quite famous. What about akka? Do you know other big users of akka?
Yeah, so LinkedIn is was one of the first users, and it's interesting because there were a tweet the other day from Lightband. So Lightband is basically the guys that are maintaining and akka, and they announced that Fortnite was actually running on akka, and they were here to manage up to, I think they say like 12 million user sessions at the same time. But it's quite, I was not expecting this technology. I didn't know it was good in the video game industry. Well, I think it's actually a good example to actually share all the workload on the lifetime event, especially for video games, because you need to have a very low latency.
Thank you. Next question. How many akka and Kafka instances does it take to run a service like yours?
Well, you get two scenarios. The first one is business as usual. And basically, you could have, if you don't have any activity on the platform, you could reduce the number of nodes to 1. It's not actually something we're doing. We are running, if anything happens, we have an average of 3 to 4 instances per region that are started, just to make sure web servers are here for any kind of load. And then all our processing cluster, it's basically, it differs from one day to another. It depends on the load. So each time we got new transcoding tasks to manage, we are booting instance. And when the transcoding task is over, we are killing it. So it can be from 0 to 1 to 3 to up to 100. It really depends. I cannot give you the accurate answer. It's varying all the time, but from a daily basis, 2 to 3 web servers is just enough to make sure you can answer all your daily workload. What is interesting here, if you know about cloud infrastructure, when you got something that is called spot instances, that are basically low-cost instance, it's really an ideal situation because you can actually kill any machine and having the cluster that is respreading all the business logic across all the nodes. So you can have really, for a very low cost, you can have a minimal level of service running. That's the cool thing about that.
Thank you. And another question. Do you use different model for machine learning, I guess the ML sensor? And if yes, does each node has its in memory?
That's a very interesting question because this is a challenge we have at the moment because when you are, I think you're talking mainly for here computer vision because when you are talking about NLP and audio, the memory is not quite high, but this is actually one challenge because you got two paradigms. You could either have one universal model that works for everyone, But let's say if you got a customer that is teaching the machine to learn a new pattern, if you are updating it live and you are just have a single model, it will be updated for everyone. So that's really a key challenge. So actually, yes, that we could do this choice, but from the beginning, we didn't go that way. We choose to make sure each customer has its own model. So we got a root model, like a basic logos and people we already know how to recognize. But then, as soon as users are starting to create and teach the machine to recognize new patterns, it will be only accessible to their workspace. And it is a major trade-off from a memory perspective. That's, of course, it's harder to maintain, but this is more from a privacy point of view. We did that choice.
Okay, and a last question from me. On all this multimodal analysis, did you develop everything yourself, or you're using open source tools or other products?
Yeah, so we use a couple open source tools and frameworks like PyTorch or this kind of AI and ML framework. From the very beginning, when we started, and on the first proof of concept, actually, we built 2 or 3 years ago, we tried few AI services on the shelf. And I won't mention the name of the company, but well, you have it, you name it. And that there were kind of 2 issues actually. The first one being false positive. So you got some service that can actually detect a person that are already well known. And we were working at France Télévisions that time, and we were working a lot of on the burial of Johnny Hallyday. And we were trying this service. And on most frames where we could see Johnny Halliday's family, they were saying that in the church, Renée Zellweger, which is the actress that is playing in Bridget Jones, was actually near in Johnny Halliday's family. So you don't understand, well, we are in France, right? We are in a church. Why is there an actress from Hollywood here? And actually, the system was mistaking Renée Zellweger with Hélène Darroze, the famous French top chef, right? So maybe they're blonde, okay, maybe there is kind of a similarity, but I'm not quite sure. So from this day on, we realized that you cannot actually trust the machine, and the way you are training a dataset is very, very important. And that dataset used by this provider was used with a HOG technology that is now a bit dated. It was not really using new deep learning technology. So that's where we understand that and the importance of multimodal approach. And the second thing is the cost, right? So when you see computer vision cost is so expensive, and we cannot be smarter about what we analyze or what we don't analyze, right? So if there is only black frames, we won't analyze black frames. There is nothing in it. If there are, it's the same thing. Like when you are working with, we're working with the AFP, because sometimes a camera waiting for someone to speak up. So you get flags that are moving, but nothing really happens. So why would you trigger computer vision over this kind of image? And so that's why we did this choice from the very, very beginning.
Okay, thank you very much, Frederic. And yeah, Rachel, you can obviously reach out to Frederic if you have any additional questions. His contact details are in the event information. I have his LinkedIn and all his information. Okay, thank you, Frederic. We'll go on to the next talk. And yeah, but Nicolas, you should really drink something else than coffee, even if you're in Portland. So on it, next talk is from Romain. Let me just. So our next talk is from Romain, who's going to talk about how the standards that we're all working on are made, and who is making them, and but actually working under the hood.
Hello everyone, my name is Romain Bouqueau, and this is an insider presentation about how our standards are made and why they work. That's why I called it From Standardization to Conformance, the making of your favorite media standards. Because we use their acronyms every day, H264, HEVC, AV1, MP4, CMAF, MP3, AAC, VVC. But what do we really know about these names? It's time to know more. Some of you may know this quote, "There's method to my madness," from Hamlet. We're going to see that in standards, that's exactly what's happening. It doesn't seem always logical, but there's a good reason for things. First, let's go back to a definition. What is a standard? According to Wikipedia, it's a formal document that establishes uniform engineering or technical criteria, methods, processes, and practices. Practically, it's a several hundred pages document written in tiny characters with cryptic tables, like shown on the right. Reading such document is tedious, and most of the time you don't only have to read one document, but these standards are interconnected, so you have to read several of them, or at least refer to several of them. And dealing to such an amount of data is clearly non-trivial, and some people made their careers on the fact of being able to read these documents. And on top of it, if you know how to program, of course, you're the king of the world, or at least you could be part of the GPAC licensing team. About this subject, I think it was pretty well covered on our blog, so I put the link. If you want to know more, you can have a look. Standards, who? In theory, anyone can participate, but in practice, the companies and the countries showing the highest R&D expenditures trust the contributions, the honorific roles that give you the strategic perspectives, control, and way to put your patent in the standard. As a remark, from my consultant point of view, many people in many companies are attached to the responsibility of following the standardization effort, but they are too passive. And it's a huge mistake. When you spend some R&D money and resources, and if you don't attend actively, you deprive yourself and your company from a powerful strategic tool. And as a consequence, as you understand already, there's a bit of winner takes all strategy in standards that materializes as a race for being the first to have access to the information, to implement the standard, to be the first to have a full working workflow, or of course to be part of a competitive IP offer. I put this quote from Alan Kay: "The best way to predict the future is to invent it." This is exactly what it is about. The people involved in the making of standards actively are writing the future, or at least a path that could become the future. But when you think about it, it's difficult not to use what has been invented already. For example, a video codec compresses pixels, and we've been doing this for more than a lifetime. I mean, MPEG-1 video is almost 30 years old, and even H.264 AVC, which is extremely popular, is from 2003. That's 70 years old as of today. So it's beyond the patent lifetime, which is mostly 20 years. But most of these things are stuck and have led to the situation that we've known for HEVC, and let's see for VVC, because the patent situation is concerning, and especially in the US. Because in the US, 75% of the patents that went in front of jurisdictions that were challenged, as they say, were invalidated. Clearly, it means that the majority of the US patents are non-valid or maybe garbage. And in the US, if someone sues you, even if they lose, you need to cover your own legal fees. As an example, in France, your legal fees are covered up to a certain point, of course, if you win, which means that if you're small, you're probably not going to see a lot of big companies suing you for no reason. And if you win, of course, it costs you some time and energy, but it won't likely cost you a lot of money. But in the US, these small companies and individuals are not in an equal position when facing a lawsuit. And this had created the patent trolls. I think we can make a full presentation on patent trolls. And now we have patent police, companies like Unified Patents looking to debunk invalid patents. It's just crazy. But let's move on to where the standards are made. Standards are made in standardization bodies. There are not so many of them. We could technically list them, but it's not what is interesting for today. For the record, the word standards only applies to a document that has been approved by national bodies such as the ANSI for the US or AFNOR for France. And once all the nations have voted, then it becomes an international standard. Technically, there's a process. So you can push your own technology as a new standard if you follow strictly the protocol, which is not always easy because it's a bit cryptic, and of course there is some politics on top of it, allowing some opponents to try to slow you down. This is exactly this crypticness that led us to have 3 video standards in MPEG those days: VVC, EVC, and LC-EVC. Your other options, if you want to make a specification that people use, is to publish it on a less selective organization. Less selective, but it doesn't mean that it's less good, of course. For example, IETF. Or if you're good enough, you can have your own de facto standards, such as SRT or RTMP. And, whatever is the status of your document, even bad specifications find their way. For example, HLS is now an IETF official RFC. I think it's clear at this point that there's a lot of politics in making a standards, because if you consider the making of a video codec, so you want to make a standard, it means that there are several actors with different interests who will agree on a set of conforming streams. So for example, you have people like Netflix interested in VOD, you have broadcasters or encoder manufacturers that represent their main customers, broadcasters, pushing for live, etc. So it's not a question of compromises. When you make a feature easy for one of the participants, you sometimes, and most of the time, make it harder for another. So it's a question of balance, and that's why I'm saying that, there is a political side in making a standard. So we agree on the set of streams, but the different standardization bodies don't describe the same part of the standard. For example, MPEG describes the behavior of the decoder, and they have a clear definition for it. A compliant implementation of a standard is a client which behaves correctly to any syntax described in this standard. Let me repeat it. A compliant implementation of a standard is a client which behaves correctly to any syntax described in the standard. But this is not the case for all the organizations and standards. For example, at IETF, generally, they define the behavior of the server. Or at W3C for HTML5, they describe the expected behavior, of course, of the decoder. even for non-compliant content. This is a bit subtle, so I put an example on the right. And on the right, this looks like random content, but this is from a compliant stream. And to give you my opinion, what MPEG does is the only way. The second point is that people compare standards and more complex standards, which is a situation that we usually call fragmentation. Fragmentation is not necessarily an issue when you have enough interoperability, when you can exchange one standard by another, and it's what standards are made for, right? Interoperability. And this assumes that the connection between the standards are made accordingly to a layered architecture. So we can easily imagine how it works for a codec, because basically the layer of the standards is similar to the layer of the architecture of services or the architecture of software that we have to design. But then you realize that for some technology, for example MPEG-, the bounds are not clear. And when it's not clear, you can extend up to a point that make your life more complex than expected. And to keep on the example of MPEG-, that's probably why it took us 5 years to gain traction and interoperability around it. But fragmentation also leads to this. You all know this one, I guess. There is always someone trying to unify things, and this usually doesn't give birth to the single unified technology that we'd like to create, or even the best technology. And if we consider Dash, as I said before, or GStreamer, or many other technologies. But the good news is that it's avoidable. Because when you have a standard, you then have some other things to do. So of course, the main goal is to have people start using your standards. But the interesting part of the standards and the interoperability stuff is that you allow actors who usually don't communicate together to have a common format. And you really want to manage this as any project or things that you want to deliver. Of course, there's going to be bugs, and you want to discover them the earliest possible. And when it's software, you can update it, so you can update the document. Of course, when it's implemented using hardware, it's a lot more complex. And then you can do other things that can improve the standards. So you can make extensions, of course, that's the easy part, but you may also want to invent some restrictions that would allow people to start in an easy way with your standards. You know them as profiles. For example, for H.264 AVC, there was the base, main, and high profiles. When you try to make an implementation, what helps a lot is to have access to the whole workflow. When you want to make a decoder, you want to have access to an encoder to be able to have the input bit streams that you're going to give to your decoder. And when you make an encoder, you want to have a decoder, because what you encode, you want to check that it looks like what you initially planned to encode. Now, when you think more carefully about this, when you make a decoder, you don't need an encoder. You need some bit streams. And especially some bit streams with a good coverage of the specification to give you confidence in your decoder. And the same for encoder. You don't need a full player, but you need a tool that checks that your bit stream is syntactically correct. So if you hear about this for the first time, it looks like a chicken and egg problem. But the good news is that this topology of problems have already been solved by Elon Musk, as seen on our right. So aside from the humor, the solution is already said. It's called conformance tools. For the decoder, you need a set of bit streams with a good coverage. We have companies like Allegro DVT doing that for video codecs. And for the output of encoders, what you need is a conformance checker. Note that doing these conformance tools is often mandatory as part of doing a standard. But let's go back to the user now. From a customer point of view, so if you're an encoder manufacturer, so if you're an engineering team, having a conformance checker is okay. The conformance checker is going to give you cryptic messages that point precisely on the rule that you violate on the standards. But if you're running operations, you want something that we call a monitoring tool. So a monitoring tool is basically a conformance stack with an additional live view. So on the right, I put you an example of the Motion Spares ATSE3 monitoring tool, where you can see live the structure of your services and have some conformance information about your services. To be able to build such a conformance tools, first you need to take the standard, to extract the rules from the standards. So this assumes that the standard lists the rules explicitly, which is a rather new idea. Old standards doesn't list explicitly the rules, but now they do. And once you have the list of rules, you need to implement them. So again, it means that you have someone able to read the specification, the other specifications which your specification depends on, and be able to program. So it requires a lot of knowledge to be able to implement such a tool. And of course, when you're working on such conformance tools, the first question that you have is the standard correct? This is called soundness. And to try to solve this, you need to go at a higher level and try to imagine a language that would allow you to describe the standards so that you have a model of the standards. And of course, the problem is that we don't have such a language. But there are some interesting projects like Kaitai, for example, trying to express all types of syntaxes. But again, there are some limitations. They cannot parse all the patterns from our standards because, either the packaging MP4 standard or the video standards have some really strange patterns. And the second point is that they then expose the standard in a way that doesn't make it easy to post-process. They are not suited for this. So once you have this language, imagine we have it, or we have something that is acceptable for us. We want to use this language to express some parts of the standards. And once you have this, you can get a lot for free. You can have parsers in any language. You can use the model and the abstract tree that you can extract from it to generate some bit streams, etc. And for the people who are really technical, you can have some solvers where you say that you want to have some specificity on the bit streams. For example, you want this bit with this value, this bit with this value. You run a solver, so especially SMT solver. And you can generate bit streams that have the properties that you want to have. This sounds like really complex, but doing a simple model is quite easy and it works beautifully in practice. It's just that when you need to apply this to a standard that is several hundred pages long, of course, this is complex. To be clear, So I've been working with other people on such a language, and as I've just said, it's practically just half the way. But it already helps a lot. For example, if you're doing your own codecs, so they are the open codecs, but there is a lot of people doing proprietary things. Because of the advantages of getting so much things for free once you have the model for your codec. And what is interesting is that you can go beyond the media industry, because these techniques derives from other industries already, like CPU makers, to make sure that the CPU instructions and implementations are okay, security, networking, etc. The only problem at the moment with standards and conformance is that the business model is not always trivial. That's all for today. I think we dug already quite far. And last, I'd like to present myself. My name is Romain Bouqueau. I'm a programmer and an open source and standard contributor. I've started at Allegro DVT, but working on the transcoder side, so doing some video quality and performance. Then I moved to Telecom Paris Tech to work on open source. And in 2012, I've started life as an entrepreneur. So I've founded MotionSpell and GPAC licensing and some other startups. You can find all the information on my LinkedIn. Thank you. Thanks for the organizers at Paris Videotech. And if you have any question, please let me know.
Thank you, Romain. So if you can join me to answer potential questions we have.
Sure, everybody.
Yeah, and so that everybody can see how all the hair salons are closed in France. And okay, we have a question from Nicolas. Romain, how can we prevent the emergence of patent trolls at the standardization step?
That's a good question. I'm unsure to be the right person to answer this, and I think, Nicolas, you will have the opportunity to ask this question to Mickaël Raulet from ATEME, because he's going to talk about VVC. But I think that there are organizations trying to prevent this. The problem is that people push their technology, but they didn't agree a priori on some baseline about the exploitation of the technology. So I think everybody knows what happened with HEVC, where probably the worst conditions from the contributors were unacceptable, and HEVC got a very limited life in the industry. And since we have a lot of more codecs like VVC, EVC, we had AV1, etc. Of course, this patent question is asked. And for example, what happens with AV1, in my opinion, is quite interesting. AV1 is supposed to be royalty-free, and the people doing AV1, so the Alliance for Open Media, AOM, so basically they have a pool of money where if they think that there is a problem and they will need to buy the patents, they can buy the patents. And at the same time, they do what I say in one of the slides, which is that they pay for lawyers to check and to challenge the patent validity. Because, as I mentioned, in the US, the problem is that 75% of the patents, when they are challenged, they are dismissed in front of a court. So I don't have the answer, but I think that there is a mix of both. First, try to set the patent holder's position as soon as possible, and the second one, have a patent police that is able to threaten the people that would be too greedy by explaining to them that if their patent was challenged, there would be a good probability that it would be invalidated.
Thank you. And I have one question myself. So you talked a bit about MPEG at the beginning. what the fuck? What's happening with MPEG? So is it dead? Is it still alive? I got an email saying it was dead. So
Yes.
what's happening?
That was a question from the conversation as well, so it's good that you asked it already. So, okay, the founder of MPEG, started a new organization that is, out of it, which is called MPAI, with a strong focus on AI. It's quite interesting, I think, but it's totally separate from MPEG. In practice, things will continue to run according to what MPEG used to be. And the only difference is that MPEG got promoted in a way, and now it's been split into different groups and different types of groups because there were so many things at MPEG. Like MPEG was in the smallest type of organization at ISO, so it's international standards at ISO. It was the smallest possible organization, and it was one of the most productive. So it needed to be split in a way or another. So the previous meeting, so there are 4 meetings a year. The last meeting was the first one with the new organization, and practically nothing changed.
Okay. And yeah, maybe one last question. Do you think we'll ever see the video standard that will unify them all, or is the technology too complex? Then we'll always have different standards out there.
It's possible that we get disrupted at some point, not only about video, but about many things. Maybe it's just a matter of time. The thing is that the technology is getting more complex, and probably we don't put enough money to do this because, companies, they want to make easy profit. They want to go to the market as fast as possible, etc. So at the same time, you need to put a lot of resources in R&D and get a strong perspective on things. I think one example, for example, is that video codecs, and there are people talking about codecs after me. Mickaël is going to talk about this. He's an expert. So the codecs, the way they work is that you take the picture, and basically you make a grid out of it. You make blocks with several granularity. It's scalable, but you take these blocks and you compress them, and that's what we've been doing since GPAC. But at the same time, we have better technology, for example, wavelets, that allows us to scale up and down, with a better transformation and a way that allows more easily to get scalable codecs. That's what Vinova does, for example. So basically, that's why the codec can rely on a layer which is, I don't know, AVCH264, and on the top of it, you can extend it to something that allows you to scale. So it's a kind of upscaling, the upscaling is better. You can make some better predictions on top of it. So it's actually a good way to do it. And, I was surprised that VVC would use this, block-based compression. Each new generation is a surprise. It's like we have a highly optimized horse, and we don't know how to replace it with a car. So, once the car is ready, or the electric car is ready, yes, there's a possibility that one is going to rule them all. Yes.
Okay, so thank you very much, Romain. Obviously, you can reach Romain. Yuri even put his LinkedIn in the chat. Now it's the time for half an hour break, so you can fill your glasses and do something else. And half an hour, 25 minutes, 26 minutes now. 25 minutes, so I'll see you at 5:30. All right. Welcome back, everyone. I hope you had all time to fill your glasses and all ready for the next two talks. So the next two talks are going to be about what's new on CMAF. First, Patrick will talk about the impact of CMAF on your workflow, mostly focusing on dynamic ad insertion and DRM. And then Mickaël will talk about what's new with VVC, CMAF, and low latency. So let's jump right into it.
Good afternoon, everyone. I'm very happy to be in this Paris Videotech meetup today. We now have the standard evolution for both DASH and HLS to address the low latency live OTT delivery. This was required for sure, but this is not enough to be able to deploy at scale most of the commercial services. Indeed, monetization is key and workflow must be adapted for both the DRM and DAI to have it working properly. In this presentation, I will address this very important topic. My name is Patrick Gendron. I'm Innovation Director at Harmonic, and I'm also co-chairing the live group at the Streaming Video Alliance. My presentation will therefore have two main parts. I will start with a short overview of the CMAF-based low latency streaming solutions, and then I will jump into a second part, more focused on the monetization of the low latency services, talking about digital right management impact on this workflow and the digital ad insertion. So let us start with an overview of the current situation on the different low latency solutions that use CMAF. CMAF created many industry expectations. The first one was that it makes possible some common workflows and common caching of the content all across the network. So that means encoding once, package once, and cache once, which is very important. So we just have two different manifests. And from the beginning, encryption was identified as a hot topic because it touched some legacy hardware, but I will come back on that later. Overall, CMAF should improve the profitability of the services, as the delivery chain should be made more simple. And the third point and third big expectation of CMAF is that for live content, CMAF is often associated with low latency thanks to CMAF chunks. And we can say that as of today, CMAF is now seen as the format to achieve low latency on par with or faster than broadcast. So where do we stand today? We know that after a standard to be published, there need to have some implementation and deployment. It takes time. The whole ecosystem needs to be matured, and this is what we had with Dash, where the needed element to do some low latency Dash using CMAS have been published in early 2017. We made at Harmonic our first demo at IBC the same year, and it took around 2 years to have the ecosystem maturing with specifically some new players coming to maturity, providing some new algorithm to estimate properly the bandwidth. And we had our first commercial deployment with our VOS 360 last year, in fact. On the low latency HLS side, we could see a faster, accelerated ecosystem maturity with a first draft spec from Apple coming early 2019, and then the final spec, second spec coming end of April this year, And what is important is from the iOS 14 delivered in September this year, all the Apple devices now support natively this low latency feature. So thanks to this new standard now being well established, we can exhibit some nice drawing with a convergent stack with one common set of media file, one common scrambling. So this is the big picture, but let's go into more details because there are still some remaining pain points that need to be addressed. So I picked three of the main remaining issues that come with low latency. So the first one is that, as I explained before, first experiment we made with starting with Dash in CMAF showed that player had some issue to estimate the bandwidth. And this is something that create a lot of question on the stability of these low latency services. The player has made a lot of work creating new algorithms to estimate the bandwidth, and this is now work in progress with some implementation that provide good result. The second issue, which is a link and attached to one big promise of CMAF, which is to have a single set of media files. As of today, we still need two sets of media files for low latency. This is on one side due to the way the segment and derivative chunks are made in different way between HLS and Dash. And the second thing is also linked to the DRM and more specifically on the encryption. I will come on that just in a minute. The last thing is about the digital insertion, which is a complex topic and which become even more complex and more challenging in a low latency environment. And here we need to adjust the workflow. So there are some organizations like Dash Industry Forum, CTA Wave that are currently working on those remaining pain points to so that to properly document the solutions. Well, let us be realistically optimistic and consider that the industry will, with the relevant SDOs and industry forum, will tackle the remaining format-related issues. Then we can consider that we will have soon a really common format with CMAF to distribute low latency services on both Dash and HLS. But then comes another question, which is about how to monetize those content. These are often high-cost content. Just think about sports content. In this area, there is nothing fundamentally different when it's about low latency from the regular services. Both digital right management and dynamic ad insertion are the tools that can be used to monetize. But in a low latency environment, there are some additional constraints that may arise due to more streamlined delivery timing. This is what we will explore in the coming slides. So let us start with digital right management. So CMAF didn't make a choice in the standard between CTR and CBCS encryption. Both are possible, but the industry made it for and selected CBCS very clearly. Now the major DRM systems support CBCS encryption, being Fairplay historically, but also now Widevine and PlayReady. That being said, migration to CBCS only asset will not be made in one day. It will take time because there are still devices on the field that do not support CBCS encryption. This is, for example, PS4. This is some TV set, Samsung LG TV before 2020 model do not support CBCS. So selecting and taking the decision to move to a CBCS only asset, so removing the CTR asset from the delivery is something that should be made per service, considering what are the devices that you want to reach. Do you have all the device under your control? And in this case, maybe you can consider that you don't have any non-CBCS compliant device. So this should be really done depending on your device reach. Generally, looking at what low latency can bring in terms of constraint, we do not consider that low latency per se brings some additional constraints when it comes to DRM protection. So let us see what makes interoperability complex for DRM protection. The topics that I listed here are more general issues, not really related to low latency only. The first one is that we have various DRM systems, which means different implementation across different devices. This we know is a subject of potential interpretation and difficulty in terms of implementation or on integration. Second point is that there is not one single approach for content security. Different approach regarding initialization of data carriage, secure key exchange, key rotations. So different approach means different possibility to interpret things. And last but not least, there are some optional features, some not well defined, not well specified feature or aspect in the MPEG common encryption specification. And all this need to be clarified, and CTA Wave is currently working on this, providing more details or on document all this so that to ensure that we can have or we can minimize interoperability issue across the device. So let's move now to the last section on dynamic ad insertion in low latency services. The AI is another opportunity for the distributor to monetize the content. But support of server-side digital ad insertion had some complexity in the workflows. And doing this in low latency brings some additional timing constraints. We didn't find a critical issue in the way the workflows are built, brought by the low latency feature itself, but we could see that the workflow need to be adjusted to cope with more strict timing constraints. In details, looking at DAI and HLS, we can see that the solution may differ between low latency DAI and low latency HLS. So just to illustrate what is a generic DAI workflow as described by DAI Industry Forum, there are many elements with many interfaces in between. So we don't have enough time now to go into more detail, but let's see that it's generally involve several elements: packager, encoder packager, manifest manipulator, the ad server, and the OTT player. So those elements are often coming from several vendors, and the interaction between those elements, which is in general information of with a timing associated to that, need to be described. This is what DAI Industry Forum made so far on regular latency services, and there is a need to complete this work with low latency. extending this view to a broader, including the playout that produce the relevant CTA markers that will trigger the ad insertion. We can see that this ecosystem goes from the scheduler that provides some triggers sent to the manifest manipulator that had to exchange with the ad server, and manifest manipulator then, once he receives an answer from the ad server, can produce some targeted manifest to the clients. So everything is rather complex, and for sure, when you say complex, this means that there are some potential interoperability issues that can go together with that. The first thing is it's complex to get a seamless transition between the main content and the ads because you need to do that frame accurate. You need to have a proper content preparation with good boundaries on the segment with ideal good behavior between renditions. Moreover, in general, the content stream have typically more features than the advertisement. So this can be more rendition, this can be more audio, and all this should be managed in a proper way. And in general, you need to make some trade-off in the implementation so that you have a solution that will work for any device, being high-end or low-end. And you need to really figure out how, if the system is too complex, it will be more complex or more difficult to have it working without significant bugs. But let's go to what the specificity of low latency and taking the low latency dash case. So for sure, it brings some additional constraints on low latency workflow because the manifest manipulator needs to receive the SCTA35 message some second in advance so that it can then interact with the ad server to retrieve the proper URL of the ads. But the way the standard it is made in a standard way for Dash, having multi-period manifest doesn't fit. The reason is quite simple to see, is that normally Dash create a new period when an ads come. In a regular latency, this Scotty message is inserted in the new period that is sent to the manifest manipulator, and the manifest manipulator has some time to exchange with the ad server so that to replace in this newly created period the segment. This cannot be made on low latency environment because when this new period is created, the player is already decoding the currently being created segment, and there is no time to give the proper URL of the ad segment. So the solution here is to create an early available period that will be sent to the manifest manipulator ahead of time, and before this period is completely known. And then doing that, the manifest manipulator can initiate the exchange with the ad server and prepare the ad content. And then depending on whether the ad is replaced or not, and this is again a decision of the ad server, the segment of a period n+1, the newly created period, will be either live content or VOD assets. What about low latency HLS case? So first of all, this has been taken into account in the low latency HLS specification. So you can go to the Apple WWDC made in June, and you will find a nice video by Roger Pontos explaining how this should work. But that being said, the problem is not really on the delivery, but this is more like in Dash, in the way you should prepare properly the playlist. So there is more or less the same problem as the one we have in Dash, and we need to signal in advance the Scotty message in the playlist, so that to make sure the manifest manipulator has the time needed to work on it and to exchange with the ad server. So overall, I spoke probably more on about server-side ad insertion, but you have pretty much the same issue in client-side ad insertion. So here are my takeaways. So we have standard and ecosystem now ready for low latency Dash and low latency HLS. Monetization is very important, and on DRM and encryption side, the issues are now a good way to be solved thanks to good work made at CTA, for example. And on the digital and assertion side, so low latency brings some more complexity. This needs to be well documented. There are solutions, but still some work to finalize this. Thank you very much.
Thank you very much, Patrick. If you can join me to answer a few questions.
Hello, good afternoon.
Hello, Patrick. Yeah, we have a question from Nicolas. Can't we cover both low latency HLS and low latency Dash dynamic ad insertion with a single set of ad segments and two delivery manifest approaches through the byte range addressing scheme and chunk transfer encoding?
Okay, maybe I could make a short answer saying yes, but let us wait maybe 30 minutes. My guess is that Mickaël will talk about this byte range addressing scheme to have some common workflows.
Okay.
I don't want to disclose what Mickaël will tell us.
No worries. So maybe a more generic question. So you talked about those implementation. Is this still a lab matter, or do you have deployments going on those low latency with dynamic ad insertion and DRM out there?
Yeah. So correct. It has been a long way, and still, I believe some time to have a fully matured ecosystem being Dash and HLS for sure, which is more recent. We just had our first deployment, as I said, last year, and I believe it was not without any DAI or DRM. All those things will take time. There are, in fact, two types of problematic. For the DRM, it's more kind of optimization, because having two sets of media files because there are two encryption is something that can be done. For DAI, it's a bit more complex because you need to have the solution that makes it possible, simply. With Dash, to my knowledge, at least in Harmonic, we do not have yet a commercial deployment in place. We have the solution that I very briefly explained using early access period and this general scheme. For HLS, it's even less mature, but there are some tools like date range that in the HLS toolbox that should make it possible. But yeah, this is still some time to, after, let's say, the past 2 years, we had a lot of demonstration of the formatting. Okay, yes, this is fine, it's stable, players are now working properly, have good reliability. It's also put some pressure on the network because you cannot make some low latency on the poor network. It has to be a decent network. So this were the type of trials we had. But then now that this is starting to work, our customer come back to, okay, now I think about a real service, but I need to go to either DRM and or DAI, and this is the purpose of my talk.
Okay, another question.
A topic for next year. Hopefully, this is a topic for next year. We probably will have more live big events next year. I hope so.
I hope so as well. Another question on the ad ecosystem. My experience, at least from the ad ecosystem, is that it's a mess. As in, all ad servers are, creating video files with no very, they have mono bit rate where you have multiple bit rates. It was an issue even before the dynamic ad insertion. It's an issue with the dynamic ad insertion without low latency. So do you see a new ad format or a new complete workflow for the ad, or do you need to own actually the ad processing workflow to make that work? Or
first, I fully agree with you that it's kind of mess, complex. Sometimes one integration per system and different, difficult to have something common. At least the intention of the hope through the work that has been carried out in Dash Industry Forum, in CTA Web, is to try to make people converging on kind of a good way, or good, let's say, to give some guidelines. I don't know, and to be honest and pragmatic, we probably won't reach a single absolute way to do, but at least if there are some guidelines to make it easier, that would be great.
Okay, and you talked a lot on the packaging, on all the content preparation side. Does all that impact the CDN and the video delivery side of things?
Sure, it does, and it's for those who follow the little history on low latency HLS with the first specification, where mandating H2 push feature, which was not supported on every CDN. So that's the reason why there was some, worth noting is Apple finally made a big change to its specification to take into account real world, I would say. So of course it took some time, even on the Dash side with check transfer encoding, which is a feature available maybe for 10 years or maybe more. We had some CDN that did not support and had to work on that because they had some older device, not fully software, I would say. So yeah, it brought some challenges to the CDN. I hope that now it's on good way with some solution for the case for low latency HLS. There has been adjusted so that it can be realistically deployed in solution where it is often with multi-CDN, so you cannot just have half of your devices being able to be in low latency and the other half, and all this being dynamic. You really need to have something working everywhere.
Okay, thank you very much, Patrick. I don't think we have any other questions, so we'll move on to the next talk. Thank you.
Thank you.
So next talk is Mickaël from ATEME, who is again also going to talk about low latency Dash and HLS, but less on a business point of view, but more on the technical, on all the updates, what's new on all those, and as a bonus on VVC as well.
Hello everybody. So I'm Mickaël Raulet, I'm CTO at ATEME, and I will present you what's new with low latency Dash and low latency HLS and I will also speak about what we are doing with low latency on VVC. So on the next slide, I'm presenting the workflow that we were working on for low latency dash and low latency HLS, and for that we use CMAF. So we use our product that is the encoder packager in a single box, then we push that to an origin server. The content will be pulled from the CDN and then provided to the player. So that was a webinar that we did together with Akamai and TO. So here I will present mostly what we are doing on the encoder packager on the origin side. So the format that we use is CMAF for common media application format, and this format is quite important in the rest of the presentation. So CMAF is only a container, so that's just the FMP4. It does not provide playlist or manifest, but it gives a convergence between HLS and Dash, since HLS was relying on TS and Dash was relying on FMP4. So CMAF is only the container, and it was pushed by Apple and Microsoft to provide a single container, and with the idea of reducing the cost on the CDN, on the cacheability, and also to reduce the complexity on the EDN. So as said, it does not provide the manifest, so some of the people will use Dash, some other will use HLS, and some other may use another format that might be just the JSON format that is representing how to present that to the player. I said before, so CMAF has been initiated by Apple and Microsoft. So it was proposed as an MPEG standard in February 2016. And it was somehow a fast track because everything was already almost there. So it's more or less a profiling of FMP4 plus some external boxes to say that we are using CMAF. So the specification was finalized in July 2017, and the standard was published in January 2018. So as said before, it's really a fast track for a standard at MPEG, so less than 18 months. So in May this year, we did another webinar that was promoting low latency dash. So we did some work mainly after the guidelines was available. So it's a guideline coming from the Dash Industry Forum in March 27. So we did some experiments with Akamai, for instance, that was just releasing its CDN to better support low latency dash. In these particular guidelines, they provide some open source tools like FFmpeg. They are using FF Labs also for the origin server, and they are using dash.js for the playout. In the previous slide, I speak about low latency dash and the specification that we have in place that is based on the dash.js specification. Here I will speak about the low latency HLS and the IETF specification. So the low latency HLS offers new functionality, so it has some burden on the origin server. So the generation of partial segments, so you may have partial chunk. The blocking of the playlist, and then the playlist delta updates. When are you updating the playlist, since you need to provide that to the player more often than before. And you need also to block and preload the media segment. We are now at revision 8 of this specification, and the link is provided on this slide. So I will speak about the low latency with CMAF, mostly the link between the packager and the origin. So what is a fragment and a chunk? So if we use dash, traditional dash, when we send a 2-second segment, we need to store it before we can send this information to the next equipment. We do that every 2 seconds if this is the 2-second chunk or fragment that we are using at the packager. When we are doing low latency dash or low latency HLS, what we do is that we provide the chunk, the low latency chunk, and we concatenate that to provide a fragment. So we can send the low latency chunk or the chunk more often, every 500 milliseconds in this case, to create a chunk in the end. So instead of having to wait for 2 seconds, you can wait from 500 milliseconds only. And you can do that for all the chunks after. So when we do low latency dash, we push in chunk transfer encoding. So we use the same for low latency HLS. So the CMAF chunk that we are pushing are the same from the encoder to the packager. We just use another way of providing this information is that the playlist that we are pushing is based on byte range. So for low latency dash, the difference with dash is that the manifest contains 3 keywords that are quite important. So the availability time complete and the availability time offset. So here we use 500 milliseconds for the chunk inside the fragments. So we have 3.5 and 4 seconds for the fragment. So we have 3.5 for the availability time offset. Something that is quite important also in a low latency dash is that you refer to an external URI that is providing the NTP to the playback. So the playback is not relying on its own clock, but is relying on the NTP. And here we use the Akamai NTP for that. Just an example. For low latency CMAF with byte range, you provide the size of the chunk. Here it is 0.5. So you need to block them during 1.5 seconds. So that's the can block reload that you are putting on the origin server. For the fragment itself that are 4 seconds long, you can decompose them here into 8 chunks, since we are using 0.5 seconds for the low latency chunk. So the byte range, we are using the byte range here, and for the byte range on the right of the at, you are having the start, and on the left of the at, you are having the length of this particular chunk. So you have 8 chunks to compose a fragment. And when you are close to the edge, you have the keyword preload in, so you are at the moment preloading this particular chunk on the origin server. So for the LL-HLS with CMAF, so when we are doing the playlist with part indexing, so we are not using byte range anymore, but we are indexing it with a number. So then what we send to the origin server is just a small chunk, not something that is growing chunk by chunk. So that's why we are using that for in between the encoder and the origin server. So we have the same information. So the part target is 0.5. So that means that we have 0.5 seconds for the length of the chunk. So we still have 8 fragments, since we have a fragment that is 4 second duration. So this is what we are having. We have a single independent chunk at the very beginning at the moment. We are planning to add more, but that's the current implementation. And we have also the preload int that is at the end, so delivering the information that's the chunk that is under delivery. So low latency with CMAF. So there is a need for H2 when we are looking at the HLS low latency specification. I will explain where we are using H1, where we are using H2, in which part of the component. So in between the encoder and the packager and the origin server, we are using H1. In between the origin server and the CDN with Akamai, we are also using H1. And Akamai is doing the translation between H2 to H1 when they are clients or players that are asking with H2, like the iOS devices. And then when you use AV Play inside Safari, you use H2. But there are some other players that are only capable of handling H1 that can be used for this particular delivery scheme. So there is not a big demand for H1. It's better to use H2 since you have a better appropriate ping, for instance. You have the information about it, but you can still use H1 if you want to deliver it in low latency mode. In terms of interoperability, so that's what we did in May. That was quite important to test with various players and to give a clear feedback where we stand. So where we have to do most of the work is on the origin server. Since the CDN and the playback, there were several already working. So we did some experimentation with various CDN vendors, Akamai, Alibaba, Amazon, and Nvidia. We did various tests also with various origin servers, so MSL4 from Akamai, NGINX, Amazon, Media Store, and also own-made origin server. On the playback side, we tested with various players, so Dash.js, GPAC, some mobile players like Visualon, NextPlayer, and also via Access Orca. LL-HLS, we have done less interoperability. So the origin we use ATEME. On the CDN side, we use Akamai, that is handling one of the requests that have been asked to IETF, that I will come back later on. And then we use TO, Apple, and Shaka as the playback. So now I will come back to the link in between the origin server and the CDN and explain the feature that we have been added on top of this particular origin server, since it's not a purely Apache player, but it has to do more things, so it's not just WebDAV. So the origin server on our side is handling the playlist in byte range that we are pushing from the encoder. So we use byte range when we push from the encoder. So when we use byte range as a demand, then we deliver byte range to the CDN, but we are also doing the conversion on the fly in the index mode, part mode. So when we are doing low latency chunk, so when we are delivering only the low latency part, so we are delivering that to the CDN. So the origin manages the generation of partial segment from byte range. The playlist delta updates, it's also blocking the playlist, the reload of the playlist. It's also blocking the segment download and doing the preload ins. And it manages, that's why we are only at the moment connected to the CDN of Akamai. It's also managing the open request and the IETF specification. So if the player is going to ask in between a fragment, so we can ask for an open request. This open request has been clarified by a max safe integer. So when you ask for a chunk that is in between a fragment, then you can ask for an open-like request with a max safe integer, and then you are getting the object once after the other without requesting them much. So I will explain what it looks like. So we are pushing, as I was saying, in byte range. So we are doing the in-chuck transfer encoding. So we are doing exactly the same in between low latency dash and low latency HLS. In between the origin server and the CDN, if you deliver the low latency chunk, they will progress like this. And if the playback is asking for a chunk that is not a low latency chunk, he will ask it from the origin server. In case of byte range, what you are doing is that you are progressing on the origin server. You can also progress on the CDN, and then if a playback is asking for the 2-second chunk, it will have it complete, so it doesn't have to request another 2-second chunk. So here on this slide, you are seeing a comparison in between low latency dash and low latency HLS. So on the right, you are having low latency dash. On the left, you are having low latency HLS. So you are seeing the progress of each of the fragments on the right with dash, and you are seeing also the request to the manifest. On the left, you are seeing also the segments that are progressing with low latency HLS. So you are seeing the same mechanism, is that the segments are progressing step by step, but you are seeing also a lot of requests on the playlist. So every 500 milliseconds, we are getting a request for the playlist. Now let's speak about what we have done recently. So the first slide is not really targeting the same that what we did for the previous part of the presentation, is that it's not related to Dash, but it helps understanding what we have done and why we have done that in this direction. So the first one is the trial that we have done in June with SES, so a satellite operator. So VVC is the next-gen codec. It will be ratified in July 2020. It has been ratified in July 2020. So it's really a recent codec, and we did this experiment a month before they ratified the codec. So we were using a pretty old version of VVC. So at this time we were using VVC version 6.1, so under specification at the moment, and the first implementation of MPEG-2TS that was a draft amendment at this period of time. So we provided an offline UHD content that was using exactly the same preset that real-time UHD encoding. So we demonstrated that with Vidéo and IETR. On the next slide, that's more recent, that's a channel that we have on air right now that is using low latency dash. So in November 2020, we put that on air, and it's still available till the 15th of December. So if you want to ask for a demo, you can contact innovation@ateme.com. So the partners of this particular demos are coming partly from the FEG project, since it is where we are doing the development. So there is the Explorer, there is Akamai, there is Telecom Paritech, and also recently VLC added the support of Dash, of low latency Dash, inside their player. So we are using the FVIS, so the Final Draft International Standard. So this time VVC is compliant, and we use an early implementation of the ISO-based media file format. So that will be probably CMAF after that is doing the Dash delivery. And we are doing the live encoding in 720p to 200 to 4K layers, and we are doing the real-time decoding with VLC. The VLC demo looks like this. not using the full CPU, so it's quite high, but we're already capable of doing USB decoding and encoding in real time.
I think this is it for the demo. So thank you very much, everyone, for attending this first event with almost no technical issues. We published a couple of polls, so please answer them to tell us if you like this. I would like to thank again all our speakers, Frederic, Romain, Patrick, and Mickaël. And I would like also to thank all the people who organized this. And I forgot, actually, sorry, I forgot for the questions. So yeah, you didn't not ask any questions, but I have a few for you. Mickaël, if you can join me to answer them, please. Mickaël, can you manage to join? We actually practiced this part beforehand, but
I was not willing to access to my webcam.
Okay. Thank you, Mickaël, for your talk. So we talked a lot about low latency. So Patrick had his talk on it. You had also this talk on it. So is that really the OTT answer to broadcast latency? Will we reach broadcast latency consistently for a big audience?
For big audience, that will be the question after that. So at least what we are seeing is that we are approaching what we can do for broadcast and a lot today. So we have, like Harmonic was doing, we have done several demos, and we can see that even sometimes we can go even faster than what we are doing for broadcast. So that in the end, that's not coming from the CDN or the origin server, the impact that we are getting. So after that will be the player that will be really close to the edge. That might be challenging for it to adapt to the bandwidth. So in the demo that we did, in general, we don't have any issue in this particular aspect. But in the end, in the 2-second segment that we are using, if we do that, then they can adapt to 2 seconds at least at the player side. So it will be not so far from what we are having for the broadcast, and we won't have the latency that we are having for the broadcast in between the broadcast and the OTT right now. So that will be shorter than what we get at first. And we are also optimizing a lot the head-end with these particular techniques. So it's also something that, because we are backward compatible with a standard player, then since we are optimizing the head-end, we have also a better, even with standard player, we have a better latency today. So everybody's working also on the head-end at the same time that some are working on the back-end. So okay. It's a parallel track.
Yeah, but all those improvements on the head-end will also improve the latency for broadcast,
yes.
no?
Yes.
Yeah. And a quick question on VVC. VVC is based on a lot of the same technology and same concept as HEVC. So do you see it having the same patent issues and royalties issues than HEVC, or how can it go around it?
I hope not. So there is a group that is working. That was not the case for HEVC. That is working on besides VVC. So it's called Media Coding Industry Forum. So MCIF. And the goal is not to have several patent pool and to have let's say to have a single one. So they are discussing together and they are trying to reach a common position. So there are not multiple. You don't have to do multiple demands when you are a broadcaster to adopt this technology. And at the moment, it seems that they are willing to go in the same direction and not to do the same errors that what they did for HEVC. So there was something also that was done for H.264 that was available for this particular codec that was managed by Apple and Dave Singer. So the MP4IF, and in this particular forum, they managed to handle the fees for AVC, and they want to do the same today for VVC. So I hope that they will succeed. Let's hope at least, and then we will see. So there are some counter, let's say, codec. So EVC, we were discussing that also during the presentation of Romain, LCEVC. So there are some alternatives, but in the end, I would say at first, at least, it's the one from GVET, so the one from ITU and MPEG, the joint organization, that should succeed in the next few years. So this is what we are demonstrating here with the first demonstration with an open source implementation. So we did it also with GPAC, and we did it also with VLC. So we already have some. Let's say some open source tools that will be shortly available also for doing this decoding, and we are waiting for hardware like everybody, because that's how it works. We need some hardware decoder, otherwise the deployment will not start.
Okay, thank you very much, Mickaël, and I'll leave Nikolai. Can you join for the ending word of this? No. Yes, he's coming.
Well then.
Erika, yeah, everybody's here.
Yeah, I can join. Well, thank you very much, everyone, for attending this event. Yeah, it's time now to drink. If you have some wine or beers with you. No, I hope you enjoyed this new format that we experimented for the first time. Please give us your feedback on the tool, on the format, on the speakers and talks, of course. And yeah, please answer the questions, the poll questions that Simon has posted to see if you would like us to organize that again in the next months. And maybe if you also would like to have small events to have like video industry networking in small groups, maybe that's something also we have been thinking of. And well, again, thank you for all the speakers. Thank you, Simon, for presenting for the 4 hours and asking the great questions. And yeah, I think that's it. Am I forgetting anything, Aika?
Yeah.
Yeah, thank you to everyone.
Merry Christmas, Happy New Year, and see you next year.
Yeah. And thank you to everyone who helped us out behind the scenes. So Philippe, Jules, Gaspard, Cyril, the other members of Paris Videotech.
Yeah, thank you, everyone. And good night. And hopefully next time we'll be able to go meet for some beers at this point.
Yeah, hopefully. Well, apparently it's not for the next 3 weeks, but
yeah,
you'll see that. All right.
Okay. All right. Bye, everyone.
Bye.